real numbers. We're just going to identify and then develop additional properties. And we're going to do some proofs with that one. So our basic properties of real numbers. Over here, it tells you the property and it gives it in algebraic terms. And over here, it gives you an example in numerical terms. So A, B, and C are any real numbers. They could also be variables or they could be algebraic expressions. And type of algebraic expression could be like 4x minus 1, so variables and numbers. The first property we want to talk about is commutative. Commutative property of addition. So what it's saying is if we take two things and add them together in the order of A plus B, I can switch that order and it's still equal, so B plus A. So for instance, if you take 3 plus 5, you would get 8. And if you took 5 plus 3, you would also get 8. Commutative property also works for multiplication, so it doesn't matter the order. So 2 plus 7 is 14. Well, 2 times 7 is 14, and 7 times 2 is 14. That's commutative. You can switch the order, and the answer is still equal. Then we also have associative property of addition. Let me go back to commutative. The way I remember commutative is that if I switch the order of the m's, it's still equal to the word commutative, right? It doesn't matter the order of the m's, they're both going to be there and it's still going to be equal. Associative has to deal with parentheses. So if I have 3 items, A, B, and C, and I'm adding them all, I can either group together A and B and add them and then add C, or I could group together B and C, add them, and then add A. So for instance, 4 plus 2 plus 3, and I group these two together, that'd give me 6 plus 3 is 9. Okay, over here I grouped these two together, and I'm going to get 5. And then plus 4, that's also 9. It doesn't matter the grouping. So the way I remember this is I could put parentheses around 3 letters, like CIA, and it's still the word associative. Okay, well, I could put 3 letters around ASS, and it's still the word associative. Haha, ASS. Yeah, so moving the parentheses on addition or multiplication, it doesn't change the answer at all. Okay, so the same associative property works for multiplication. The grouping of parentheses is still going to result in equal. Continuing on, we also have distributive, and you've seen distributive before. It's when we are adding or subtracting inside of our parentheses, and then we're multiplying on the outside. We're multiplying whatever we added or subtracted with the outside number. So that multiplication could be on the front, it could be on the back, it could be addition in the parentheses, or it could be subtraction. What this is saying is you're multiplying the A times the B and the C and adding it together. It's the same as if you added it together. So if I add the 7 and 3 together, I get 10 times 4, that's 40. Or if I just take the 4 times the 7 and the 4 times the 3 and I add that together, I'm also getting 40. Okay, so sometimes you'll often see the distribution, like I call them claws, 6 being multiplied to 5 and the 3. Additive identity. I remember this one is if we're adding, first of all, additive identity. Like if you look in the mirror, you see yourself, you see your identity. So what has to be added to A so the result is itself? Well, 0. 0 is the additive identity. 9 plus 0 equals its identity of 9. What do I have to add to 9 so that it equals 9? 0. So the additive identity is 0. Multiplicative identity, so if I have a number like -5, what would I have to multiply it by so that it equals its identity, it equals itself? And that number would be 1. So times 1 is the multiplicative identity, and plus 0 is the additive identity. Those two things will give you that number that you started with, or letter, or algebraic expression. Okay, so those are identities because we found their identity. And additive inverse now. Think of inverse as opposite or flipped, because let's say we have a number like 3. What do I need to add to it, or what's the inverse of a positive 3? Well, that'd be a negative 3. So we're adding the inverse. It always gives us 0. Same is true if I have a negative 4. Additive, the inverse of negative 4 is a positive 4, and those two added together will always equal 0. So the answer to additive inverse is always 0. Multiplicative inverse. Well, when we're talking about inverse and multiplication, let's say we have the number 8. The inverse of 8 when we're multiplying is its reciprocal, so 1 over 8. The answer to a multiplicative inverse will always get you 1. So for instance, if I had negative 7, the inverse of negative 7 would be negative 1/7. Okay, so we're just flipping it on multiplication. And the answer there would be 1. Your answer is always going to be 1 on multiplicative inverse. Identifying properties. So let's say I gave you this example A. You have to state which property is being used. Well, let's just identify the left side. So I kind of break it up on the equal sign. And I look at the left and I say, okay, what property is going on from the left side to get it to look like the right side? So here I have 4 times the quantity A plus 3, and over here I have 4 times A plus 4 times 3. So it looks like they used distributive property. Number B, again, I look at the left side of the equal sign and the right side. On the left side I have 6 times 1/6, and on the right I have 1. So I can go back and I can look at these and I can try to find something that looks similar. Oh, that looks almost similar. That's the multiplicative inverse property. But if I didn't already know that, or I didn't have my notes, I'd remember that the answer to a multiplicative inverse problem is always 1. So the answer here is 1. I know this must be multiplicative inverse. Okay, because 1/6 is the inverse of 6. Down here, negative 3 plus, and then parentheses 2 plus b. And I have the same exact order, negative 3, 2, and b. But what has changed? The plus signs are the same, and the negative 3, 2, and b are all the same, but the parentheses have moved. Okay, so I'm thinking back, where did I see parentheses moving? Oh yeah, associative property. Now I just need to decide, was it addition or multiplication? And this one was addition. We were adding in between them. So this was the associative property of addition. And the last one, I'd like you to pause the video, try it out, and then type your answer in. Okay, so you notice that on the left side we have b plus 8 and then plus 0. And on the right side we have b plus 8. Okay, so what's different on both sides? Well, this side we're adding 0. We're adding 0 on the left. And it's equaling this expression that we started with. So I need to figure out which property is when we add 0 and it equals what we started with. So if I go back, oh, here's one where we added 0 and we got what we started with. So that's the additive identity property. So you should have got additive identity, not inverse. Identity because we found its identity. B plus 8 is what we started with. If we add 0, then we get that identity back. Okay, now let's, instead of identifying, it tells you what property to use, and it gives you the left side, and we have to come up with the right side. So we're using associative property of addition. If you remember, associative is we can move the parentheses and it doesn't change the problem at all. So the parentheses are around the b plus the 8 And then we have plus 3. Okay, so what I want to do is instead of putting parentheses around b plus 8, I'm going to put them around something else. So everything else stays the same. The b, the 8, and the 3 are in the same order. The plus signs stay the same. But let's pick up those parentheses and put them around the other 2 items in this equation or in this expression. And now we've just used associative property of addition. So we did that one. Down here, additive inverse property is saying, okay, 0 equals 5c plus what? Okay, so we always split it up on the equal sign. What do I need to add to 5c so that it's equal to 0? Additive inverse. I need the inverse of 5c, which would be negative 5c. If I add those together, I get 0. Okay, so I've just used the additive inverse. And the last one, go ahead and pause the video and use the distributive property to come up with the right side of that equation. When you use the distributive property, remember the 4 is being multiplied by everything in the parentheses. So I have 8 times 4, and then I have y times 4. And what sign is going on in between? Oh yeah, subtract. And you could do this further. You could go one step further and say this is 32 minus 4y. I'd accept either of those answers. Okay, so we have more properties of real numbers. The properties over here, they can be proved using the basic properties that we learned earlier, the first and second slides. We're going to prove them after we talk about them. So let's talk about them first. Properties of equality. So these properties are the ones that allow us to solve equations. So if I had x plus 1 equal to 7, I can solve this by subtracting 1. Well, this subtracting of 1 on both sides is actually a property. Okay, oops. So let's talk about these properties. Addition property of equality. If we have something equals something else, just like I set up my equation, something equals something else. It could be numbers, it could be letters. Let's just start off easy and put numbers. 7 equals 7. If 7 equals 7, then I can add something to the left side. And if I add that same something to the right side, it's still going to be equal. Okay, so I have 7 equals 7, and I add 1 to the left, and I add 1 to the right. Are these still equal? Yeah, I have 8 and I have 8. They're still equal. Okay, so if we add the same thing to both sides, my equal sign is true. Multiplication property is the exact same thing, except instead of adding to both sides, if you multiply the same number, so let's multiply by 2 on both sides, is it still equal? Yeah, it's still 14 and 14. And the same is true for subtraction, but now it's not called the subtraction property. It's called, so instead of adding something, we're going to be taking away. So let me back up. What I mean is, let's say I have x plus 1 equals x plus 1. So I'm adding the same number on both sides. I'm adding 1. If I took that 1 away, if I canceled it out, in other words, subtracted it, I'm left with x equals x, which is true. Okay, cancellation property of addition. Cancellation property of multiplication. Same thing, but now it's multiplication. So let's say I'm taking it times 2 again. If it's times the same thing on both sides, cancellation property says, hey, you don't even need those. X equals x. Okay, it's what allows us to divide by the same number on both sides. So think of this one as subtraction on both sides, and think of this one as division on both sides. Properties of 0. The multiplication property of 0 is saying anything times 0 is 0. 0 times 7 is 0. A times 0 is 0. Anything times 0 is 0. And you can write that there. Anything times 0 is 0. Division property of 0 is saying if you take 0 divided by anything, your answer is always 0. 0 divided by 7, 0. And then the division property by 0 is undefined. Okay, so this is division property of 0, and this is division by 0. By 0 is undefined. So in the top one, it's okay to have 0 in the top. Down here, it is no good to have 0 in the bottom. If you type in 7 divided by 0, it's going to be undefined in your calculator. And then properties of negation. What happens when we multiply by -1? Well, we get the opposite of it. So it's saying if I take -1 times 7, then I get -7. If I take -1 times -8, well, I get the opposite of that, so 8. Placement of negative signs. It depends on whether it's inside the parentheses or outside. It's saying that it's equal. Let's say you're multiplying -3 times 2. It's the same as multiplying 3 times 2 and then times the negative, or it's the same as multiplying 3 times -2. Okay, kind of think of the negative as a -1. So it's 3 and 2 and -1. Doesn't matter where that negative sign goes, as long as it's on one of them. And then the product of two opposites, which is saying negative times a negative makes a positive. So -2 times -3 equals a +6. Okay, now let's get into our proofs. Proof of the cancellation property of addition. So here's the cancellation property of addition. It's saying if A plus C equals B plus C, then A must equal B. Like, why can we just cancel? That's what we're trying to prove. And the hint is use the addition property of equality. Okay, so with any proof, you always want to write the original equation. So here's the original. And what we're trying to get down to is that A equals B. So I always write what we start with and what we're trying to finish with at the top and at the bottom. And the book is nice. It gives you each step the proof. So we don't have to come up with the proof. All we have to do is list which property is being used. So the first line is the original equation. That's my reasoning. Okay, so this side's the math, this side is the reasons. So it goes step by step. So from the first line, what did they do to get to the second line? Okay, so let's look on the left and right side. I have A plus C on the left side for the first line. And look at the second line. I still have an A plus C, but we added something. Okay, and then over here I had B plus C, and then to get to the second line, they added something. And I noticed that that something on both sides is the same. So what did they do? Well, they added the same thing on both sides. What property is that called, where you can add the same thing on both sides? So I go back and look. And we're adding, so it's not going to be any of those, not going to be any properties of 0, and we're adding. So it's either going to be addition property of equality or cancellation property of addition. All right, so let's look at the example here. This one, we're starting with two things on the same side, and then we get down to canceling. No, that's not really what they did in that step. We're starting with two things equal, and oh, we added the same thing on both sides. So this would be the addition property of equality. Yep, that's my reasoning. So we gave you the first one, addition property of equality. They're adding the same thing on both sides. Okay, so now let's look from the second step, how'd they get down to the third step? All right, so let's see the difference on the left side. I have an A plus C plus a negative C, A plus C plus a negative C. So nothing's being added to both sides, nothing's being subtracted. I haven't changed the order at all. I haven't changed any signs. But look what they did. There was grouping around A plus C, and now look where the grouping is. So what's that called when we change the grouping in an addition problem? When we change grouping, I think of associative, right? You can put parentheses around AS, or you can put the parentheses around CIA. By the way, don't abbreviate associative ASS. Abbreviate it ASSOC. Associative prop of addition. We can change the parentheses, move the parentheses around. And that's what they did on the right side. The parentheses were around B plus C, and now the grouping's around C plus negative C. Okay, so we filled in the property for the third line. Now we're looking at how do we get from the third line to the fourth line, and we're naming that property. So what happened? Okay, a lot of stuff is different now. A plus C plus a negative C changed to A plus 0. Okay, so my A stays the same, but now this grouping part became 0. So C and a negative C added together equals 0. Add together two things, one's opposite, and the answer is 0. So let's go back. Here's the properties of 0, but there's nothing about adding. So let's go back to our basic properties. Oh, here's some stuff with 0. If I have A and the opposite of A, and I add them together, I get 0. Oh my gosh, that looks like the one that we're on. C plus a negative C equals 0. So this is the additive inverse property being used here. Additive inverse, not identity. Additive inverse. Adding these gets me 0. And the same thing on the right side. They used additive inverse again. Okay, so one more that we have to do. We have to get from the fourth to the fifth. And let's just look at one side here. I have A plus 0, and then it changed to A. So how did they do that? What's the justification? Why does A plus 0 give me A? Okay, A plus 0 gives me A. I remember seeing that. Oh yeah, here it is. A plus 0 gives me A. Yeah, A plus 0 gives me A. Kind of like 9 plus 0 gives me 9. Okay, so that's the additive identity property. Guys, I know these are kind of hard. This is the first time you've been seeing this. But what I want you to do is just pick one side and go down step by step by step. How did they get to the next step? What property is being used? Okay, last slide here. Let's fill in the proof. So this is number 41 in your book. We're trying to identify the property over here off to the side. So the first line in every single proof is always going to be the original equation. So that first one's easy. Boom, we just got a point on WebAssign. How do we get from the first line down to the bottom or to the second line? Folks, when you're doing this, you can pretty much just ignore one side. So how do we get from the top line on the left to the second line on the left? Well, what's different? I still have an x plus 5 in both of them, but what did they add? Oh, they added something. So what's that called when we add something to an equation? And you can go back, we did it here. We added something. It was called the addition property of equality. Addition property of equality. You can add the same thing on both sides and it stays equal. And that's what they did. They added the negative 5 on both sides and they still wrote equal sign. So this was the addition property of equality, and we're just going to abbreviate that. Addition prop of equality. How do we get from the second line to the third line? What's different? Well, the x is the same, the 5 is the same, the negative 5 is the same. The grouping has changed, though. There's no longer parentheses around the first two numbers. The parentheses are now around the last two numbers. So moving the parentheses is the associative property. And we're using addition because associative works for multiplication and addition, but this is addition right here. Okay, how do we get to the next line? What did they do? Well, the x is still there, but it looks like they added the 5 and the negative 5. So that's the addition property of something. When I add a 5 and a negative 5, oh, those are inverses of each other. Added an inverse, that's the additive inverse property. 5 with a negative 5 makes 0. Okay, last one. How do I get to the last step? I went from x plus 0 to x. So what property says I can add 0 and get itself? In other words, get its identity. This is the additive identity property. That one was very similar to the one that we just did. Okay, over here. Remember, we have the math part and we need to say the properties part. Here's the original equation, 3x equals 15. What we're trying to prove is that x equals 5. Well, I already know x equals 5, but how did we get there using properties? Okay, so let's divide it down, the equal sign. And let's look, how do we get from the original, remember I can ignore one side, down to this line here? What's different? The original had 3x, and now this line has a 3x, but something's being multiplied to it. 1/3, that kind of looks like a reciprocal. So if I go back and look at some of my properties, do I see any reciprocals anywhere? Not on this page, but on this page I had a reciprocal. Oh yeah, that's multiplicative inverse. I'm multiplying by the inverse of 3. So I'm going to write multiplicative inverse. Okay, how did I get from the second line to the third line? What changed? I still have a 1/3 and a 3 and an x, but where did my parentheses move to? The front. So moving parentheses is always the associative property. And remember, there's two associative properties, so this would be associative property of multiplication, not addition. All right, after I move the parentheses, how did I get down to this line? The x stayed the same, but this 1/3 times 3 changed to a 1. So what's that called when you multiply by the inverse and you get 1? Oh yeah. Multiplicative inverse we've already used. But when my answer is 1, what property is that? Go back and look. When my answer is 1, multiplicative inverse property. Oh, you know what? I messed up earlier. I used inverse and it should have been identity. Multiplying by 1 gives you its identity, so let me go back and change this. Oops. Okay. It does look like multiplicative inverse, okay? But multiplicative inverse, the answer has to be 1. So that's down here. I'm sorry. And if I confused you, just raise your hand and call me over and I'll help you out. Multiplicative inverse. The answer to a multiplication problem is 1. It's multiplicative inverse. So what allows us, though, what property up here allows us to multiply by 1/3 on this side and 1/3 on this side? What property says we can multiply by the same thing on both sides? So you go back, go back to the basic properties. Multiplicative, what says we can multiply on both sides? Oh yeah, equalities properties. Multiplication property says, hey, if you have two things equal, let's just multiply this side by 1/3 and this side by 1/3, and it's still equal. That's what they're doing here. They're using the multiplication property of equality. So let's abbreviate that. Multiprop equal. Multiplication property of equality, we multiply by the same thing on both sides. Associative property, we move the parentheses. And multiplicative inverse, we got 1 as an answer between a multiplication problem. Okay, so last one. How do we get from 1 times x to x? This one's not so obvious. Well, we're multiplying. And we're multiplying by 1. And we're getting the original problem. So x times 1, and we get its identity. If we're multiplying by 1, that's the identity property, and we're multiplying, so multiplicative identity. It gives you itself. Distributive property. Okay, I have full confidence that you know the distributive property, so I'm going to make you pause the video and work out these two problems. Okay, the answer to the first one, if you use the distributive property, just rewriting it, this is the rewritten form, 20 times 2 plus 20 times 5, and then you could solve it and get 140. Sometimes WebAssign will ask you to solve it down to a number, or it'll ask you to rewrite it, and this is the rewritten form. Over here on 18, rewritten form would be -4 times 10 minus -4 times b. If you did work to simplify it down, your final answer would be -40 plus 4b. It's trickier when there's a minus sign in between. So if you treat it as a minus sign, then this would be a positive b, and then you have subtraction in the middle. So you'd get minus a negative, which would just turn it plus a positive. Minus a negative is plus a positive. Okay, remember, if you have any questions, please feel free to ask, and I will clear anything up. Don't get frustrated on the proofs. Ask questions, and then most of the proofs follow the same order. So the more notes you keep on the proofs, the better prepared you'll be on the test.